All right, my friends, so welcome to SAT Practice Test 4. We'll go right ahead and get started. As always, the first dozen or so are generally pretty quick. So if I go through something too quickly, you can always go back, watch a little bit slower. You can post a comment. I'm happy to answer it for you. So we want to know activity 3 here. So activity 3 is going to be right here, a little bit below 40, so that should be 39. Number 2, our percent proportion model, we've got of as our denominator, that's our whole. We've got is our numerator, that's our part. Is the percent out of 100, so we have 75 out of 300. We should be able to simplify that as 1/4. We should know 1/4 is 25%. For number 3, if I cross multiply, since the 36 is out of 1, I get x squared is equal to 25 times 36. Now, if we want to do this without the calculator, which I always think about even though I know we have it, I've got 5 squared times 6 squared, so taking the square root of both sides will just be 5 times 6. Alternatively, if you multiply it out, you're going to get 900, and the square root of that is going to be 30. We have a literal sort of equation here, 3 more, or a verbal model, 3 more than 8 times a number, so 8 times a number, and then we've got 3 more than that is equal to 83. Nice and easy, choice D. All right, we always see a couple of these linear models here. So we've got our constant, that's our initial value, our starting point, our fixed fee, and we've got our rate of change, that's the amount per month, per day, per year. So it says that we have monthly deposits, so 25 is the amount that we're increasing every month, 100 would be the amount that we're starting with in the account. Number 6, obviously we're doing 27 divided by 3, which is going to be 9 pounds. Number 7, it says we paid $27, but that's with the $63 coupon. So without the coupon, we would have had to pay $90, and we bought 9 bins. So 90 divided by 9 is going to give us $10 per bin. All right, for the next one, we have a linear equation. So they are nice. They give us the y-intercept, which is 29. So we realize those are out. We can realize either using the slope formula or just looking at this, that for every 1 increase in x, we're increasing our y values by 3, so that's going to be my slope, so it should be choice A. Choice 9, we have similar triangles, so the corresponding angles will be equal, so angle Q will be equal to angle T, angle P will be equal to angle S, and obviously the right angles are equal. So, and they even tell us that, right? P, they have to, right? P corresponds to S. It says angle Q is 18. Right, so that means that T is also going to be 18. So obviously we do 90 minus 18, and that's going to give us 72 for the other 2 angles. And they're asking us to find the measure of angle S, which we already said was going to be 72. All right, so these questions generally, if you use the sign of the slope and the y-intercept, you can get rid of all the bad choices. So my y-intercept is going to be somewhere around 10. So obviously choice A and B have y-intercepts that are 9/10. That's no good. We see that the slope is clearly negative, which is what we want for choice D because C had a positive slope. Number 11, it says this is the number of birds and reptiles that we can have. So it says we have 16 reptiles, how many birds? So if I sub in 16 for R, 5 times 16 is 80. So if I get 2.5b plus 80 equals 80, then subtracting 80 on both sides means 2.5b equals 0, which means b is unfortunately for the birds equal to 0 birds. The equation of our graph here, my y-intercept is -8. That doesn't really help us because they all have a y-intercept of -8. My slope is negative. I get rid of my 2 positive slopes. And we have to look at the actual coordinates, right? Because just seeing that it looks like it's 1 or -1 or whatever, the scales could be different. So the scales here are both being done by 2. So if I have intercepts here at -8 to -8, it means my slope is going to be rise 8, run -8, which is a slope, of course, of -1. Number 13. Right, so we know that if A divided by B is equal to C, then the reciprocals of these will also be true, right? Because the cross multiplication in both cases will be the same. A times 1 is equal to B times C. So if x eighths is equal to 5, then 8x is equal to 1/5. It's just going to be the reciprocal. 14 was a little tricky, right? Because, instinctually I would solve this for x first, which isn't horrible, right? If we subtract the equations, we get 18x equals -24, and we could solve it, right? We get -4/3, and then we can go substitute. So if you want to go that route, we could. Again, if I subtract here, 24x minus 6x is 18x. 48 minus 72 is negative 24. And that's going to simplify as negative 4/3. And if I simplify, let's say, into the second equation, I get 6 times negative 4/3 plus y equals 72. 6 times negative 4/3 is going to be negative 8. Plus y is 72, so adding 8 on both sides will give me y is 80. Alternatively, we can use substitution, right? So in other words, if I just want to solve for y without solving for x, I would want to substitute for x. So I'd take the second equation, which is 6x plus y equals 72, I'd multiply it by 4. So that would be 24x plus 4y is equal to 288. Now the other equation says 24x plus y equals 48. So we can either substitute, or at this point it's probably easier if I just subtract. So if I subtract, it gives me 3y equals 240. Dividing by 3 gives me y equals 80. That's maybe going to be easier, right? If you don't want to deal with the fraction, and if you're going to get frustrated if you put it in your calculator and it gives you, negative 1.3 repeating or something like that, and we should be able to fluent with using fractions, right? On the graphing calculator, we should know you can use alpha and then y equals to give you that fraction bar that we're used to seeing in the earlier grades. But we can use either method, right? We can solve for x first, or we can just solve for y explicitly. All right, this one, they give you a slope of negative 1/3. All right, so these are out, right? They're in slope-intercept form with the bad slope. And now I just need to substitute, right? So this is like 8th grade math, right? Negative 1/3 times x, which is 9, is equal to y, which is 10. And we're trying to find b. So I get 10 equals negative 3 plus b. Adding 3 on both sides is going to give me b is equal to 13, right? Which is going to be choice D. 16, it says they're modeling the value of a bank account. Okay, so it says f of 5. Well, that means x is 5. Now, what does x represent? It says the number of years after 1957. So if x is 5, that's 5 years after 1957. We're talking about 1962. So if I substitute 5 for x and I evaluate it, I'm going to get a decimal. It's going to be an approximation. It's going to be about 243. That checks all the boxes with choice B, right? The value of the bank account in 1962 should be about $243. 17 is a little bit tricky, right? So it says we have a certain rectangular region, and it says the ratio of its length to its width is 35 to 10. Now we want to make a similar rectangle, right? We want to make it proportional, right? To maintain this ratio, that's what it says. So it says the width increases by 7. So we really want to think about what that means with respect to the 10. So if it's 10, it increases by 7. What's happening is it's increasing by 7/10 of itself, which is 70%. Which means if we want to keep this similar, right, this is going to have to increase by 70% also. So the easiest way to do this is to say, well, if it increases by 70%, we're going to end up with 170% of what we started with. Now, alternatively, you can just find 70% of 35, which is going to be 24.5, which I guess is kind of what they're looking for, right? Because they don't want the final value. They want to know how much it's going to increase by, right? So doing this, the traditional way, is going to give me the final dimension. But if we want to know what it's going to increase by, right, because the width is increasing by 7, which with respect to 10 is 70% of itself, the 35 has to increase by 70% of itself. So we're going to take 70% of 35, and that's going to be 24.5. And of course, it's going to be an increase, which is going to be choice B. 18, square P has a side length of x inches. Okay. Now it says Q has a perimeter 176 greater. All right, so 176 divided by 4, right, is going to give me 44. That means the side length has to be 44 greater, right? Because if the original one is x, the new one's going to have to be x plus 44 on the side, right? Because if each side is an extra 44, then the sum of the sides is going to be 4x plus 176, which is 176 greater than 4x. Now, if I want the area, I'm going to take the side length and square it, so that should be choice A. So we're going to make our S look something like that. So we should know that the central angles of a circle are all going to add up to 360, and the arcs of a circle add up to 360, right? So an easy way to see that would be to think about if I had a right angle, right? So this right angle would be 90 degrees, meaning if I had all of them together, that would be 360, and then as a result, we measure this as 90 degrees as well, okay? Which means that if I instead have 100 degrees, well, it's going to be the same thing, right? I mean, if this is going to be 100 degrees, and this is 100 degrees, right? So R, right? So this is R, O, S. That's it, right? So that was just making the connection. I mean, we don't get too much into like high school geometry, like tangents and secants and stuff like that too much, but central angles equal to their arcs are something that we should definitely know. This was pretty hard for a number 21, right? Also, this to me, I don't know. It looks like to me like 6 to the 5th, right? I know that 5 is supposed to be the index of the radical, but I don't know. If this was on my SAT, I might have a problem with it. But we know that if that's the index, right? So let's say the square root of x is equal to, well, I don't need to put the index there, right? So the square root of x is equal to x to the 1/2, right? The cube root of x is equal to x to the 1/3. So what's the 5th root of x? Well, it's x to the 1/5. So I've got the 5th root, so I've got 3 to the 5th times x to the 45th, right? That 6 is just hanging out. And that's the 5th root. Now, that means it's raised to the 1/5 power. Now, my power of a power property says when I raise a power to a power, we multiply the powers. So 5 times 1/5 is 1. That's not so bad. And x to the 45th to the 1/5 is 9, okay? And I've still got this 6 that's hanging out there. Now I'm going to do the same thing here, right? So I've got 2 to the 8th times x to the 1st, and that's being raised to the 1/8 power, right? Because it's the 8th root, that's the index. So again, this part is going to be easy, right? 2 to the 8th to the 1/8 is just 2 to the 1st. And x to the 1st to the 1/8, if I multiply the powers, is x to the 1/8. All right, again, this is pretty difficult for a number 21. So now my coefficients become 6 times 3 times 2, which is 36. So now we have to be careful, because now I'm multiplying powers at the same base, so I have to add the powers. So I actually get 36x to the 9 1/8 power. Okay. Now, what's the question asking us? Well, it's saying that if this is A, and if this is B, they want us to add them together. All right, well, 36 plus 9 1/8 is 45 1/8. Now, technically, as a decimal, we would write it like this, but we don't have space for that, right? I think we only have 5 spaces on the grid. So if you look at the answer key, it says that they'll take this or this. Now, the second one's not right. From a rounding perspective, it's not right, but they'll take it. Now, really what we should do, right, and you know, if you've heard any of my videos, you know I always prefer fractions to decimals for a reason like this. We should write it as an improper fraction. So as an improper fraction, we get 361/8. That's the correct answer, right? Now, technically speaking, this is correct also, but we're not going to be able to grid it correctly. So I would defer to 361/8 personally. All right, so we have these 3 sides of a right triangle. So obviously, we don't care about the hypotenuse. We want the base and the height. Now we just need to know the hypotenuse so we can get rid of it, which is the biggest side. Now, could we work under the assumption that they're giving them to us in order? We could. We shouldn't. Could we put these in our calculators and look at the decimals? I guess. But really what we would want to do then is we'd want to kind of unradical this, right? So 2 radical 2, if 2 is radical 4, right, this is really radical 8. And if I unradical this, that's radical 36, radical 2, that's radical 72, and radical 80. All right, well, that 8 plus 72 is 80. So that seems like it makes sense from a Pythagorean perspective, right? Because radical 8 squared plus radical 72 squared will definitely be equal to radical 80 squared. We just get rid of all the radicals. So that proved what we probably already knew, that the base, let's say the height, race, doesn't matter. They're arbitrary. So these are my dimensions. Now, I'll be honest, I almost made a mistake the first time I did this. I forgot the half, right? I got so excited that the radicals were going to clear that I just did 2 rad 2 times 6 rad 2. So we've got 2 times 6, which is 12, Radical 2 times radical is 2 times half is going to give us 1. So it's going to be 12. I almost put 24 the first time, right? Because again, I got a little excited there and I forgot that the half, but we should be half times the base times the height. 23. So this is one where it's kind of like, just do what's the simplest, right? So we're going to factor this using constants. Okay, so there's a lot of different ways I can factor this, right? So 4x squared could be 4x times x, and it could be 9 and 5, and I don't really care. So I can figure out what b is going to be here. Again, I don't really care about that. I'm just going to say, well, let's look at my choices. Which of these is going to be an integer? All right, I don't know really anything about b, because b could be a lot of different things. If I change the sign of my 9 and 5, if I make them 15 and 3 or 45 and 1, that's going to change that. What's not going to change? Well, what's not going to change is the fact that these two numbers have to multiply to negative 45. They have to. They're telling us that these are going to be integer constants, right? So it's not like I'm going to get funny with fractions or anything like that. So those have to be factors of 45 or negative 45. So let's see. K and J are going to be factors of 45. That means 45 divided by a factor of 45 will definitely be an integer, right? So that was pretty straightforward. All right, this one gets a little tricky, right? So exactly 1 point. All right. So what does it mean that they intersect in exactly 1 point? Well, it means that when we set the system of equations equal to each other, we're going to end up, let's think about a quadratic that has one solution, right? Right, so here's a quadratic that has one solution, right? Why does it have one solution? Well, it's got one solution because if I factor it, the factors are equal. So I don't have to solve both of these equations to know that there's going to be one solution. Okay, so I'm looking for a perfect square trinomial, right? Could I also say, I'm going to use the discriminant and make the discriminant 0? Sure, you could do that. I'm not going to do it this way here, but we know that the discriminant determines the number of the roots and the nature of the roots. So yeah, if you want to make b squared minus 4ac, which is the discriminant 0, that will work. I'm going to use a substitution approach. So I'm going to say 2x squared, right? Since they're both equal to y, I'm going to set them equal to each other. And then I'm going to want to put this equal to 0. So that's going to give me 2x squared minus 24x plus 64 minus a is equal to 0. All right, I'm going to divide everything here by 2. So I've got x squared minus 12x plus 32 minus a halves is equal to 0. All right, so I want this thing to be a perfect square trinomial. So if you've done any completing the square, we should know that you take the value of b, right, assuming a is 1, you divide it by 2, and you square it. So clearly I want that 32 to be a 36, right, because then I can factor it as the quantity x minus 6 squared. So what that means is I need this thing, this negative a halves, to be the 4 that added to 32 will give me 36. So I want negative a halves to be 4, so I want negative a to be 8, so I want a to be negative 8. Okay, so a's got to be negative 8, just for the record. Not that that's super important here. But if I make a negative 8, now negative 8 is 8 halves is 4. Now I end up with what I wanted. So that part's not super important. It's more just that I can do it. So now when I factor, I get x minus 6 times x minus 6. So my value of x, and again, we don't have to solve them both, should be 6. What should we do to prove it? Well, we should check. So if I take my second equation, right, using the value of a, which really is only going to be kind of useful to check, what's going to happen is this. If I substitute 6 for x, right, I'm going to get y is equal to 3 times 6 minus 8. 18 minus 8 is 10. Well, what does that mean? Well, it means if I substitute 6 for x here and 10 for y here, it will check, and it does, right? 6 squared is 36 times 2 is 72. Minus 126 plus 64, it does give us 10. So 6, 10 checks. We don't need to go that far, but it's good to be thorough. But that's what we would do. Again, you can use the discriminant if you want. I wouldn't necessarily do it that way, but we could use the discriminant. The problem with using the discriminant is the value of c is 32 minus a half, so it gets a little sticky there, but it'll still work. All right, 25. make a little bit of space here. Obviously, you can always go back and undo what I just did there by rewinding a little bit. So it says, we've got this isosceles right triangle, right? So we've got our isosceles right triangle ratio, right? They give it to you in the formula sheet. I don't need to go back to it, right? And this is one, honestly, the 30, 60, 90 and the isosceles right. You really should have these memorized by now. XX and X radical 2. Now, what are they doing? The hypotenuse is 58. All right, so what's the leg? Well, it's 58 divide radical 2. All right, now, if you've done enough problems like this, because now we're going to have to rationalize the denominator, right? If you've done enough problems like this, and you want to do it quickly, what we do is, if you have the hypotenuse, you divide by 2 and multiply by radical 2. That's going to save me a lot of heartache, because 58 divided 2 is 29 rad 2. All right, so if you're equipped with that strategy, I'm pretty much done with this problem. Whereas if I go back to what I did in red, oh man, I got to rationalize these denominators now. I get 58 rad 2 over 2. Now I need to divide 58 by, and yeah, I'll get there, right? But certainly it's going to be a lot faster doing what I did here. So 29 rad 2 plus 29 rad 2 is 58 rad 2 plus 58, which gets us choice C. All right, this is definitely the most terrible question here. I'm not exactly sure the purpose of this question. I mean, I go back and forth. I'm not exactly sure. All right, so let's go through it. All right, so it says, we can make a little sketch here, right? So the vertex is 9, negative 14. It's a parabola. Now, is it going to open upward or downward? Well, it says it intersects the x-axis in 2 points. Okay, so it opens upward. Now, all we know then is that A is positive, right? We don't know if it's fractional. We don't know if it's super steep, right? All we know is that A is positive. And that's kind of what we're going to use a little bit down the line here, right? Because that's really the crucial piece that we need. Now, the second crucial piece is they give us the vertex. So we're probably going to need to use vertex form, right? So we've got A, x minus h squared plus k. And in vertex form, hk is the vertex. So the x-coordinate is the opposite of what's in the parentheses when we complete the square. And the y-coordinate's the constant that's outside. All right, so let me fill this in. So I've got A times the quantity x minus 9 squared minus 14. So this is vertex form of my parabola. So if you put this into your calculator, obviously you can't use A, put a value of A, 1, 2, 3, 4, whatever you put in, you're going to get that vertex. Now you're going to get various widths of your parabola, but you're going to end up with that vertex. Now what could A plus B plus C be? Well, we're not even close to there yet. So what I'm going to have to do first, and I'm sorry that my A's look like 9s, I'm going to try to do better, is I'm going to expand this. So we should know how to square a binomial. And I'm going to distribute. And then hopefully we can kind of make some sense out of this big old mess that we have here. All right, so I'm going to kind of lean on the choices pretty soon. So I'm going to go back to the fact that A is greater than 0. It can't be 0. So what does that mean? Well, all of these things are multiplied by A. So even if A is really small, right, we're going to get a value here that's going to be greater than 0. Right? Now, if I take that with my negative 14 and I look at the choices, well, I've got all those choices that are negative 14 or smaller. So I'm going to take the choice that's bigger than negative 14. That's going to be kind of the safest way to do this here. And finally, number 27. This one actually isn't so terrible. So again, I'll blot this out here. So we've got this, I guess the part that can be a little tricky is the negative that's there, because we don't see that many exponential functions here with negatives typically. I'm not saying we never will, right? So it says if we take the function and we shift it 15 down, that it's going to have a y-intercept of 0, negative 99/7. So that means that if I substitute negative 99/7 as my y value, and if I substitute x for 0, that this is going to be true, right? And we want to find the value of b, that way we can find the value of a. So this is the kind of the tricky part here, right? Is that following our order of operations. So negative a to the 0 power. Obviously, order of operations says we have to do the a to the 0, which is 1, and then multiply by negative 1. So I get negative 99/7 is equal to negative 1 plus b minus 15. So negative 99/7 is equal to b minus 16. So I need to add 16 on both sides. All right, so 16 in terms of sevenths, if we do 16 times 7, is going to be, what do we got, 112 sevenths. So this is going to be 13 sevenths. And then it says the product of A and B is 65 sevenths. So A times B, which is 13 sevenths, is equal to 65 sevenths. Well, that's convenient, right? Because we know we can multiply both sides by 7, and we know that 65 divided 13 is 5. Therefore, A is equal to 5. All right, so if you liked my video, you can like and subscribe. There'll be plenty more SAT videos coming, SHSAT, some Algebra 1, maybe some Algebra 2. Any comments, questions, concerns, please let me know in the comments in the chats, and I'll be happy to get back to you. Thanks for watching.